1 second. It won't have come up for you, will it? I've done it unlisted. This link now, but I am streaming. We'll see how bad the latency is and stuff like that. Of course, because you're in the lesson, technically you don't have to watch the live stream as well. You can just watch me. It's just so that you can go back and but I just want you to guys to just see if there's any like sort of audio issues or latency issues or whatever, and see how it works for you as well. But typically, in the new build, when we've got a merged class, it's going to make it a lot smoother for me to be able to just go and not stop, and people to chuck comments up and stuff like that. And also, it should create a sort of environment where people don't just start randomly talking to each other and stuff like that. Like, I'd rather the chat going on in a chat quietly. It will get very loud. In the new build, I've got like a 3D scan of it as well that I can show you guys in a bit. What have you done to this, Travis? Yeah, yeah, that's what I all say, mate. Test. So. Test. 1, 2, 3, 4. Test 1, 2, 3, 4. I'm not doing VC. I joined VC last night yesterday. We talked to over A. Okay, if you go onto Canvas, the stream link should be there in the announcements. Are we all good? Let me know when everybody, when you're all ready to go. Yeah, I will start talking in a second. There will be around about 30 seconds today. Yeah, it won't, like, you will hear me when I start. Yeah. What? Good. Oh, why? What's wrong with it? What's wrong with Yetis? Nah. Good. Are we? Yeah. Are we ready to go? Okay. Right. I mean, you can hear me though. Yeah. Clear. Clear. When I talk. Yeah. 14 seconds is acceptable. This is just a test run. I haven't done any balancing, and we don't have a proper recording studio, so it is going to sound a bit trash. But whether or not the lecture is able to be recorded and scrolled back through is a technical issue. What? Oh, Kelsey, what are you doing? Right. Um, just real. I could do. That's what I should do. Having to, but when I'll probably argue and then at street. Yeah, that's it. All right. I'm gonna try. Let's see. Let's see how this train wreck goes. Also, please remember that I can go back through that, and I can trace back you accounts to the person who owns it. All right, I'm gonna go now. So if you don't want to be in the stream, the final video, shut up. Also, if you do want to be, shut up. Um, right then. So the whole point of this lecture is to go over how to make cubes that you can change the shape of and get them to have different behaviors, such as either rotating like this, spiraling and going up and down, having a certain amount of delay, and you being able to choose how far they move, what direction they move, and how long they take to get there. So if I play this as well, I've also put in the logic into these so that when they hit me, I die. But I'll show you how to make that logic enabled or disabled. When I look at one of these cubes that I've created, such as this one, it has how much damage to send to the player. So if I want it to be a lift, I would probably want to send 0 damage to the player. The rotation rate of it, and obviously how much it will rotate along the x-axis, the y-axis, and then the z-axis. You've got pivot translation, and that will change the location of this pivot as whether it is over here, depending on where this pivot is moved to. So this one is being moved 500 centimeters off to the x and y. So that means that it will start pivoting from 500 over here and then 500 here. So that is where the pivot is located once it starts moving. The new location is the location that it will move towards. So it's when the game starts to play, it looks at the location where it is and stores it as its initial location, and then moves it 500 units in the X, 0 units in the Y, and 500 units in the Z. So it will go, as I'm on 100, it will go from 1, 2, 4, 5, 1, 2, 5. So it will go to there, and if I Control Z that, is back to where it was. Then I simulate this. You can see it do that. The next thing it has is a time to wait. So if I increase this and now simulate, it will wait 1 second there before it moves back. And then the final one, which is the most important part of this, is the speed percentage. So it is all based off a timeline that takes 1 second to complete. If you wanted a lift that travels maybe 500 meters, having it take 1 second, so if I increased this to be 5,000 and 5,000 and then did this, it moves pretty fast, which could fling your player off into oblivion and end up with gameplay results that maybe you don't want. You might want something doing it that fast, but if you wanted it to take longer, so we've made that 10 times the length. So if I divided that speed multiplier by 10, now it will move 1/10 of the speed, and then it wait there for it may potentially, this is the other thing that you need to, oh no, it doesn't have I was thinking that this speed percentage would affect the delay, but it doesn't affect the delay. It only affects its translation speed between the new locations, so you don't need to adjust how long it waits. This is just changing the movement speed. Just the same, if you only want it to move full amount, you could have it in very, very slowly, or you could put in a large number there, and then it'll do it really, really fast. Then there, do that, and then it has flexibility to do a lot of things. It's a fairly simple blueprint, so I'm going to go through it step by step now. And then I will show you how to create your own. I'll go through the logic that we're about to create. So this is the main logic for the lift, and this is there is also some construction script, and then there are a few elements in the components that you need to make sure that you have. So the construction script graph it's a reference to itself. It finds the axis location and promotes that to a variable as the initial location, and you can see that here as a vector. It then progresses to do the next thing of grabbing the rotating movement component, and it sets the rotation rate, and the rotation rate is a public variable and we have wrote in the tooltip that it sets the rotation rate of the block. And this being made public is what allows us to edit in the editor, so that when we copy these out, I can now independently change this variable here, and it will do something slightly different to the other one without having to make a whole new block. And then finally, the pivot translation from the rotating movement variable, and the pivot translation is what moves the gizmo around, and so that it rotates from a different location. The event graph, we start with event begin play. Every blueprint should have one of these in by default. It might be grayed out slightly for you, but it will be near the center of the blueprint, and it all emanates from this. First thing that we need to create is a custom time dilation, and this is how we are changing the movement speed of this object. We are giving it its own time in the game universe, and to do that, you get a reference to yourself. You have speed, which is a float variable, which you would have to create and make public. This one is yellow because it's missing the tooltip. So you could write there, sets the speed of time for the and then you have a flip-flop node here. To get this custom, we'll go through how to create this from scratch in a moment. I'm just going through the flow of logic first for those of you who are more confident with Blueprint. Flip-flop fires through A first, then B, and then A again, and then B. It flip-flops between the two executables, as can be seen if you highlight over it. Alternates between A and B outputs, starting with A. We have a timeline in here with a very simple alpha track. So that is a float starting at 0 and going through to 1. So 2 points that it blends between. I have set this to be auto curve, but if you wanted it to be a more linear curve, you could do that. You could even create another float track in here and then put in 0 in here, 0 here, 1 here, and 1 here. And then this would be available for you to use here to swap between. There's a useful node called select. And then what you can do is put both of these options into here. And you could create then a new variable, an integer. This is just an example of like how to expand on this. And this could be selector. And you would make that variable and then choose between linear or smooth. Get the selector and put that into the index. And when you put that into here, so into the lerp, and then if we go back to this, if I file that, now I've got a selector that I can choose between. So 0 would be smooth, 1 would be linear. So I don't know whether I can, yeah, I can break that. So that's something that I would probably have to clamp that integer. But I can choose between 0 and 1, and it would change the way that the curve will translate either a smooth or a completely linear way, depending on how you want your lifts to work. But for now, I'm just going to do that. But to stop that from being able to break, good, just clamp this between 0 and 1. And now the designer should not be able to. It does let you do that. I think even if they go out of this value, the clamp actually cap it to round it to the nearest value. I think potentially also go, yeah, slider range. You can do it in here. 0 and 1. Try that. There we go. So now I can't go out of 0 and 1, even if I try to. So you don't actually have the clamp. You can just do that. Slider range 0 and 1. Right, I delete that now. So yeah, the timeline blends between the initial location, which is what we got here. We stored that as soon as the object is constructed to store that variable. And then the new location is this variable here, and that is what we're going to add onto the initial location to move the lift in its own local space. There is a delay. The time to wait to fire this repeat function once this is finished, and then that is when it starts again to either reverse from the end or play from the start, and that is how long you can change this value, and this is also public here, so how long until platform returns. And finally, the final node is to grab the platform, which is just a static mesh. I've used the 1 meter cube, which comes with Unreal, and applied the master instance, the grid material to it. The reason why is because by default the pivot point is in the center of the cube, which is useful for when you want to make things that rotate from their center rather than have it, figuring out the pivot translation from the corner. It's slightly more versatile having the pivot point in the center of the cube. And then we are setting the world location based off these on every frame update. So it is a fairly simple blueprint. And if you want to expand on that, I would make children of this. But if you want it to be able to hurt the player, which I've given it that option, I have just created the same blueprint that we put into the def block. On component hit does implement interface, a true or false, and then an effect health. I have noticed some bugs with this, with the hit, so I am going to improve on this as I go through. But the idea is to use an on component overlap and put on a box collision on top of this platform, which scales, and you get a more consistent result. So I'm going to make this now from scratch over here. So this is now how you would do this. So you would create a new blueprint class of type actor, and I would call this platform or movable object for BP. Maybe even movable parent, something if you're going to create children classes of this. And I'm going to save that and go into it. So we need a few components. We need a static mesh, and this is fine to be the 1M cube. I've got 2 in here because one is the one that I exported and has the pivot point in the corner here. That's exactly what I don't want. I want the Unreal version, which is like this, and then I will provide it with the material like this. I'm then going to add on a box collision, and I'm going to set this to be 51, 51, 51, which makes it just slightly larger than the box by 1 centimeter. And because it's parented with the box, when I scale the box, the collision scales with it as well. The next thing that I want to put onto this is a rotating movement component. And then I'm going to select the rotating movement component and just set it to be 0. We're going to go over to the construction script. So construction script is different to the event graph. The event graph runs in-game, whereas the construction script runs also in editor. Anything to do with time can't be ran in a construction script, anything that requires on frames being run, but it can do things like such as setting variables. So it's useful to have these things in here if you want them to be set even before the game has run. So what I'm going to do is just open up the other blueprint so I've got some reference. So you can see exactly what we're building. In fact, what I'm going to do, just copy this under here so I can make it full screen. And then I'll show you exactly how. So, you start with, to create self, type get a reference to self. And then drag out of the blue pin and start typing get actor location. And we are going to right click it and promote that to a variable. I'm going to call it initial location. Then I'm using camel case here, so there isn't a space in there, but because I've done camel case, there is a space. Drag it out, and I'm going to connect up the execute. That's the first thing that we do. We need to make this public, and then say what it does. Sets the no, we don't need to make this one public. Sorry, because this one will never change. This one is just telling the movable object blueprint exactly where it is in the world and storing it as a variable so that we can add to it later. That's why this one doesn't need to be public. The rotating movement needs to be dragged out from the component section. And then from there, we need to get rotation rate. We don't want to get it, sorry, we set rotation rate. And then we want to promote that to a variable, and it's we just want to call this rotation rate. We also need to get pivot translation and set that, and also right click that, promote it to a variable, and call that pivot translation. So these two need to be connected like that and connected up here. These ones do need to be public. So rotation rate and pivot translation, compile, save. Then what you can do with this is pivot translation moves the pivot of the object so that rotation is based off of a different location. Rotation rate sets the speed of rotation. And then those two now are green tool. The next part, so go back to here and just grab event graph and just select all of this and then paste it in. So it is a good idea, as you can see, this is all quite neat. Make sure that your blueprint is readable. It's a good habit to get into. We do not need either of these nodes here. We just need this grayed out event begin play. Yeah, so we can see exactly what's going on. So we're going to get a reference to ourselves. We are going to drag out the blue pin and start typing custom, and near the bottom you can see custom dilation, custom time dilation. So we're going to set the value of that. The custom time dilation is just very similar to the time dilation node, which sets global time dilation, but this is just for the object itself. We're going to promote this to a variable, and then we are going to call this, I've called it speed percentage, because that's exactly what it is. And then don't worry about these errors here. These will fix as I create this blueprint. You won't get these as you compile. The next thing is to flip-flop out of here. Another little tip as well is if you drag down, click on this little option here, you can do a save on compile and do save on success only, which means that the game will save a little bit more often as long as you are creating good blueprint. So it's a nice option to have on. We're going to create a timeline. Timelines are always at the bottom of the list when you type in timeline. And I'll call this anim, or anim timeline even. And we will play from start and reverse from end. We will create a custom event. So add custom event, and we will call this repeat. I'm going to just put an X on the end because I've already got this custom event in down here, but I would just call it repeat for you. Put that into entering the flip-flop as well. Then, coming out of here, update, we want to set world location. And want to do that for the static mesh. So set world location, and then it will connect up the target. Okay. Now, if you'd renamed your static mesh, it might have been called. So if I'd renamed mine to platform before, it would be for that. A little bit. So you can see. So the next thing that we will need is a lerp, and we're going to need a lerp vector, and that is what we're going to feed into new location. So we're going to blend between two locations. Now the first one is going to be the initial location, definitely, because we don't want it to move from where it was. And then the next one needs to be the initial location plus an adjusted value. So the reason why we do it this way is so that we not have to type in exactly where we want it into the world. We're just adding onto the existing location already. So when we create a new variable here, choose it to be a vector and call this new location. Put it here, get it, and plug it into there. So we are adding, I'll compile this. You can see we would add, if we want it to move up, we would just add 500 to the Z, and we know we're just adding that to its initial location. That's how it works. And then we will want to make this public, and it tells us that it's missing a tooltip. So this will be adds the location to the initial starting. Adds the vector. And then we now just need an alpha to drive this blend. So we go to double click our timeline, and there's a few tracks that we could create, but we're going to add a float track today, and I'm going to call this alpha track because it is essentially an alpha. It blends between 0 and 1. I'm going to press shift and highlight and click with my mouse and set that value to be 0 and the time value to be 0 and the value to be. I'm going to shift click again, and then do this one with 1 and 1 in the timing value. If it goes off screen, you can click these 2 arrows, and we can see that there is a blend here. I'm also going to add the functionality of the second track. So we're going to do a alpha track, and we're going to do this one smooth. I can type like that. Alpha track smooth. Alpha track linear. And then I will do exactly the same here. So 0, 0, 1, and 1. And I will just select one of these and change it to auto, and you can see now how the curve changes. You could do as many of these as you wanted to now, and I'm just showing you how to keep adding that. So we're going to move this along. Make it a little neater. And I'm going to create a selector node here. We're going to promote. We can't promote that to a variable. Listen. So that here we go. If you change that from wildcard to integer, we should be able to promote a variable. And we're going to track type. And I'm going to set the slider range to 0. And I'm going to put that in here. And then the return value to go into the alpha. So in this tooltip, I will make it public, and I'm going to say 0 equals linear, 1 equals smooth. Now we can change those as we please. And then finally, after this is finished, so I'm going to move this over a little bit more as well, just so it's even more, even clearer for you to see. And I'm going to go on finished, and I'm going to drag it up here. Drag out finished and type delay. And then I'm going to promote this to a variable, and it is time to wait. And make that public. Time object will stay a location. Type in as if it was a variable. Then compile, and then finally delete all of this now. So leave it. All we need to do now after that delay, call our repeat. Repeat x. Now that should be everything that you need to get this platform to move. But to make this damage somebody, or have the option to damage somebody, we're going to get our box collision, and this is how to improve on the hit. So if I do on component, begin overlap, click plus, it adds it here. And we've all created our interfaces for characters to hurt. So if we type in does implement interface, and then other actor, and then the interface will be I damageable. Branch out of here. Quick true or false check. So if it does, pull from that other actor, effect health from I damage. Then finally promote this to a variable, and then damage to end. Public, explain to the designer who would be using this what this does. Damage to apply to collided object. And then that should be fine. We could comment this out. Say damage. And comment that, and then say movement object. So when you have very complex blueprints that you need to zoom out, you can find exactly where I've put particular nodes. To create a comment box, if you've never seen that before, it's just drag over what you want and press C, and it will create a comment box. Start typing it. You can also color these, color you like, and so you can have a sort of language for commenting for you to visually see. You can change the size of a font. You can and you can also make it so if you just select this comment, you can move the whole things that are inside of it, or you do comment and then just move that. So that is essentially the end of how to make this. Now, if you've got a good imagination, you should be able to figure out exactly how you would use this. So now you can just scale this to be whatever shape that you want. So this could be a hazard that moves up and down. If I like this, yeah. Now there are ways that you can modify this, which is what I'm going to go over now. If you wanted it to be a bit more visually interesting, you can create a material. And if I go into this and just going to create like a sort of laser material. So I'm going to make this unlit, and I'm going to also go down into lighting and make it a dynamic area light as well, so it lights the environment. Save that. Second. And then I'm just going to create a few nodes. So a multiply, to multiply the colour that comes out of this. I'm going to convert this to a parameter and call this colour. Try again. Try and name it there instead. I'm doing the American spelling on purpose, just because it seems to be a little bit easier when you work with Unreal Engine. Then I'm going to promote B to a parameter, and I'm going to say brightness. I will put that into color, and we'll grab one node called Fresnel. If I start previewing this, it does some camera logic where it says when you are looking directly at it, make it dark. Well, it depends on how you use it, but it has a blend between black and white, and white is on the edges. So if I were to put this on a cube, it can see if it's an oblique angle, it will show white. If it's straight on, it will show a sort of grey. And you can mess around with the exponents, and it will change the way it works. So if I do 0, then it will go between off and on completely. So change that now. Yeah. And the way I'm going to use this is with another lerp node. And I'm going to put that into the alpha. And I could then put this into here. And now if I make this a bright colour, so I'm just going to make this red, and then I'm just going to drop the saturation to be 0.95. Then I'm going to make the brightness 10. See, this looks like when you view it at an angle. It just changes the way it looks as you view it from different angles, which helps on things like laser beams and stuff like that. You could also, so what it's doing, hang on, is that to 0. That's what. There we go. So now you get a bit more contrast to the edges. You could blend that with a separate colour as well, but I just want it to be off on the edges. Right, so the what I'm going to do, create a tiled blueprint of this class and call it laser. And go into here, select the platform, and I think that material was new material, which was bad name. And I'm also going to scale this down here. Okay. In fact, actually, I want it that way. I've also made sure that my object is movable. I don't know. It should come in movable by default, but if you ever get in any errors saying that your object isn't movable, but your static mesh. And now when I drag this out, it's up it, and then now we've got a laser beam that avoided damage to the player. I would also just double check that the variables that we made in here are what you want them to be. 0.2 is a nice time to wait. Damage to send should probably be 0 by default. Speed percentage should probably be 1 by default, as in 100%. Track type, time to wait, a new location should be fine. Yeah, all of those are fine. The other type of logic might be that this moves automatically. So it is now up to you to figure out how to make this, maybe if you wanted a lift. So we've got something that we can step onto. If I were to go in here, how to make this movement logic, instead of event begin play, we have this on component begin overlap. So you could have, oh yeah, can't copy that out, but instead of damaging the player, if you know it's a lift, it probably doesn't want to damage the player, so you could have it be, yeah, instead of event begin play, get rid of that. Component begin overlap here. You might not want to have the repeating. You might want it to. You might have the player step on it, or might want a end overlap, and you could put that in here. This isn't for you to copy off right now, like as you're watching it. It's just for you to think about ways to change it. So you might not need repeat anymore. Really don't need any of that. I would just have this play or reverse, and then now it's you would just have to do a check as to whether or not actor. You could do a simple cast to your third person character, or you could create an interface like we did with iDamageable. You could just create a interface to put into your player, so you could add a new one here. No, not a. Just want to create a new interface that is interactable for your platforms, and then then you could do a does implement interface, and then you can see, you can choose just as we did with the damageable interface. But that sort of is for you to figure out and play around with to create more stuff for your objects. Thinking about the pickups that we made before, you could add other components in here, sort of physics emitters. We're just going through this. Yeah, so the impulse. No, hang on. I'll have a look. So if you go, I can't remember what it's called off the top of my head right now. But yeah, a radial force. There we go. So if you wanted these things to hit the player and then send an impulse, so you could check if it hit the player, fire an impulse, and then have it blast the player somewhere. You could have it affect the player, how we did before with shrinking or growing the player. You could have it obviously damage the player. Thinking about different mechanics that you've seen in games, and then having a look at other games, such as maybe having these flipping around from a different pivot, so that it's sort of all it does is rotates around every now and then does that just as some sort of platforming object. You could have them moving in and out. Just use them to make some fun and interesting gameplay. Essentially it. So that's the end of the tutorial. If there's any questions, let me know.